Welcome to this video. We're going to be talking about the composition of functions. This is aligned with IXL Precalculus A12. So suppose the price of gas is $2.15 per gallon and you drive a car which averages 40 miles per gallon of gas. How far will $20 get you in miles? To answer that question, we must first find how many gallons of gas $20 will buy, then determine how many miles that gallon of gas will take us in our 40 miles MPG car. So this linking of ideas is known as the composition of functions in mathematics. So you can think of it this way. We input price and it gives us out how many gallons we can get with that money. Then we input gallons and it outputs us how many miles. So we want to put these together into one big function. This situation can be modeled by two separate equations. The first equation inputs price and outputs gallons, and the second equation inputs gallons and outputs miles. So notice that the output of the first and the input of the second match. That always has to be the case. So the first one would be P divided by 2.15 because we take our price and divide it by how much it costs per gallon. That'll tell us how many gallons we can buy. The second one is just 40 times G, where G is how many gallons we have, because our car gets 40 miles per gallon. So together these two equations become, if I put G of P within M of G, and I can also write that with this little open circle symbol, I get 40 times P over 2.15. So $20 will get as far as 40 times 20 divided by 2.15, or 372 miles. So what I did is combine those two functions together and make a new, simpler function, f of g. And this notation is the composition of functions. So the notation for composition of functions can be a bit confusing, but it simply means the second function goes within the other. So the one closest to the x goes within the other one. So this would be f of g of x. It looks like you would want to do f first and then g, but actually you would do g of x first and then f. So it's backwards. So it turns out that if you find the composition f of g of x and it happens to equal g of f of x and they both equal just x by itself, then it turns out that those two functions are inverses of each other. So let's prove it. We have a function here, f of x, and another function, g of x. Let's prove their inverses. So first let's find f composed with g of x. So keep in mind that means f of g of x. So what I'm going to do is take g of x and plug it in for x into the f of x equation. So let's do that. So this is going to equal 2 times, and then where there's an x here, I'm going to input whole of g of x plus 1. Now 2 times 2 will cancel, so that gives me x minus 1 plus 1, and minus 1 and plus 1 will cancel and just give me x. So boom, the first one checked out. Let's try the second one, g of f, the other way around. If this also equals x, then we know these must be inverses. So remember, f of x is going to go on the inside, and that will become 2x plus 1, because right here I'm going to put all of f, minus 1, all that over 2. So plus 1 and minus 1 will cancel, and I'll get 2x over 2, and 2 and 2 will cancel, and I get x. So boom, they both gave me x, which means they must be inverses. Let's try some practice. So for each of the following, we're going to find f composed with g of x. We don't have to find both g of x, g composed with f of x, just f composed with g of x. So let's do it for the first one. So g of x is going to go on the inside, and with this first one I'll get negative 4, and then instead of x I'm going to put 2x, because that's what g of x is, plus 2. This simplifies to give me negative 8x plus 2, and that is my answer. Let's try this next one. F of g of x, I put g of x in for x here, and so I get 5 times x squared plus 4. Distribute the 5 to both terms, and that simplifies to 5x squared plus 20. And that's my answer. And that's it for this lesson. Go ahead and try some practice on your own.